SRAB Powerful Mathematics practices include 5 major indicators. This video will focus on one of those indicators, using formative assessment data.
Write down a statement that you think best matches your prediction. For me, it's important to see gaps in learning, see misconceptions, and then know how to help them from there. Basically, customizing their learning. I'm going to pour our orange mixture into each container.
The teacher purposefully poses problems that allow students to acknowledge the existence of misconceptions. The students have time to explore the misconception and clarify their misunderstandings.
Now, if you look over here at our board, these are the predictions that you are going to make based on what you see in container A or container B. And you're going to write down one of these statements on your whiteboard. You're going to write either the new mixture in container A will taste the same as the new mixture in container B, or the mixture in container A will have a stronger orange flavor than container B, or the mixture in container B will have a stronger orange flavor than container A. Take a look at what you see in container A. Take a look at what you see in container B, and write down a statement that you think best matches your prediction. Another part of this activity that we're doing is we're cleaning up some OMGs. Because you know when you text and you type, you have OMG. Well, this OMG is different. The O in OMG in this case stands for learning obstacles. So in this activity, we're going to identify some learning obstacles when it comes to understanding ratio concepts and proportional reasoning and so forth. And then M, what we're going to do is we're going to find out what mistakes do we have in our learning when we actually try to do this activity. And then the G, identify some learning gaps. Hear my voice clap one time. Hear my voice clap 2 times. Once again, let me explain to you what your task is going to be.
Formative assessment strategies should be used throughout the lesson, with adjustments to teaching and learning occurring in the moment. These adjustments should be personalized to individual students.
Work together to put the cards in order of strength. That means you're going to go from least orangey to most orangey. You are explaining that by gluing your cards on here. And you're taking turns with that work. And be able to explain or justify your decisions. Why did you put these cards here within your group? Number 2, if you think more than one card describes the same fizzy orange mixture, then you group them together and then glue them onto your poster board. Also on your poster, explain your decision.
Orange, and if there's 2/3 of a mixture of soda, I thought it'd be the same of the mixtures.
Are these 2 cards saying the same thing?
No.
Okay, I know y'all both said no. Why?
Because card J is saying there's 2/3 of a soda, and card L is saying that for every 1 soda, there is 2/3 of an orange mixture.
Oh.
I see what I'm saying. Because there's 1 soda and there's 2/3 orange, so the 2/3 of a soda wouldn't match with the 2/3 of the orange because there's 1 soda. So if there's this, it'd be 2/3 of soda, and there's 1/4 of the mixture of orange. Would it be between I and L?
I'm not completely sure.
Is there another way this can be represented? By just
A decimal?
instead of just a verbal description like this?
A decimal? Because
A decimal, or what else?
Picture?
Huh.
I think it helped us clear the problems up and work in our group and compare our different ideas and like butt heads to try to figure out the same answer. And when we get that, take it and try to figure out the next answer and clarify what we have and see if we can figure it out.
Because that's the packet and that's the soda. And it's like 1/3. 1/3 of the packet would go to another can of soda and then we'd open another packet.
So that means that every soda.
I'm just asking.
Yes.
Okay, I get it. So like, if you pour this into that, it would equal 2/3 of it, and then if you pour another one in there, that would equal 4/3, and then you have to put one of the 4/3, one of the 1/3 into that one.
Yeah, so then there would be 2/3 over here to put to another soda.
Yeah, I see. So here,
The next one would be 2/3.
so it'd be like, it would be, okay, yeah, it is what you said. So 2/3 in there.
2/3 goes over here, so we'd already have the packet. And I'd go to another one.
Yeah, it would work.
Yeah.
Saying what you did in the model. So we could put that on the poster board. Yeah, so you should definitely keep that there. We could draw it smaller. We could do this, and then we could do times 4, so you could do it 4 times. We don't have to take up that much space. Okay, I see what you did there. That explains more to it, more of it, more. That explains it more, or better.
As I was walking around, heard some very interesting conversations.
During the lesson summary, both the students and teachers should reflect on the conceptual and procedural knowledge and how they are connected. In addition, students should engage in metacognitive processes where they think about their thinking and reflect on the learning from the day's lesson.
One thing that I noticed is that most groups had an issue with card K. Can everyone take a look at card K? David, would you like to come up to the board and show what you had for card K?
Providing frequent opportunities for students to communicate understandings and misunderstandings about specific mathematical content maximizes student ownership of their own learning and allows the teacher insight into instructional adaptations that need to be made, minute by minute and day by day.
So for K, what the question was asking is for every orange juice, there would be 1 1/3 fizzy juice. So for every orange, that'd bring 1 whole here and 1/3 over here to this last one. That would bring 1 whole here and another third to this last one. And then finally, this one would bring the final third to this and have another 1 here. So that's 3 holes right here and another hole because all the 3/3 go, it's 3 out of 3 and that makes 1 hole. So you have 4 sodas and 3 orange juice.
Thank you, Dave. Hunter, can you go up and explain how, I noticed you had conversation with David as well. Can you explain a misconception that you had and how David helped you out with that?
Well, when David was saying this, when I thought that it had 1 soda and it had 1/3, we cut this into thirds, and I thought that it had just 1/3 of the orange.
One thing I'd like for you to do is bring your attention right back here from where we started from before. Now, as I was looking at your predictions, most people said that the new mixture in A was more orangey than B, which is absolutely correct. Now, what I'm going to do is I'm going to try to confuse you a little bit, but I know you can rise to the challenge. I've got 2 more containers. I've got container C, and I've got container D. Container C has twice as much liquid as container D. Now, what's going to happen this time to try to confuse you? I'm going to put 2 orange packets in container D, and I'm going to put 3 orange packets in container C. Make sure it's closed. Now this is your test on your whiteboards, just like before. In our previous exercise, we're going to see if you think C and D taste the same, if you think that container C liquid could taste more orangey than container D, or do you think container D tastes more orangey than container C? Write your predictions on your whiteboard. Can you hold up your whiteboard so we can see your predictions? Yeah. All right. Now, just like before, we'll get some people to come up and sample. Ms. Michaela? All right. Based on what you've just tasted, would you keep your prediction the same or would you change it?
Same. Or change it.
Same.
Same. All right. Maybe we'll put those down.
I think he made us do the taste test because what he was saying on the board, he was trying to get us to confirm how we could use the ratios in everyday life with the taste test and try to clarify how we did it.
Everyone, these were our standards for today. I can understand ratio concepts and I can use ratio reasoning to solve problems. These were standards that we were working on today. Now, one thing that I noticed is that we kind of struggled a little bit with that, but guess what? That's fine. That's the purpose of this lesson, to see what we're strong in and what we need some more work on. So the purpose of this lesson, what it does, it lets us know where we are and where we need to go. Think about some of the misunderstandings that you had before, and then how those misunderstandings were cleared up based on what your classmates said. Are there any further questions at this time? Yes.
Okay. So when they were like going up to when you had told us to make our decision
Yes.
about the about just now with the experiment, we were kind of like debating. What she said she had container. She thought container C was more.
Mm-hmm.
He thought it was the same, and I thought that container D would be more. I had thought container D would be more because you said that container C would have. It was 2 times the amount of liquid that container D had, right?
Yes.
Okay, so you poured 3 packets into container C and 2 packets into container D, right?
Yes.
Okay, so I had just made it like into like container D would have 2, and then the 2 packets would be 1, like 1 orange, and then container.
Keep on. Speak up, you're fine.
The container C would have like 4 like liquid, and then for it to be the same as container D, would have to have 4. No, wait. Yeah, it would have 4 liquid, and then have to have 2 because the 2 would be the 4. Like for it to be equal, it would have to have 4. Yeah. So you only poured 3 into it, right?
I poured 3 into container C and 2.
Yeah, okay. So, let me switch it. 1 second.
And see, that's one of the purposes of this exercise, to get us thinking about our thinking. Yes.
Well, he brought his prediction that he thought D would have a stronger flavor, but when I said I think it would have the same, the reason I said I think it had the same was because in container C, there's less liquid and there'd be more orange, stronger flavor. And then when you pour 3 packets in container D and there's more liquid in container D than there is C, I thought it'd be a little bit less in container D because you were pouring in 3, but there was more liquid.
And that's what we're going to have further lessons to continue to work on those misconceptions. Yes?
Okay, I think I got it now.
Okay, what did you do?
So for these two to be the same, you would have to multiply 2. And then you would have to multiply the orange and the liquid in container D by 2 for it to be equal into container C. But in container C, for it to be equal, you would have to have 4 orange packets instead of 3. But you only poured in 3, so container D would have a more orange flavor than container C would.
Here you go. Give yourself a pat on the back. You did very good. And see, that's the point of this lesson, to see what misconceptions we have, and then we correct them from there.
I feel more comfortable when it's not a grade because I stress over things. Like when we were doing the activity today, I was worried I would get it wrong and trying to make it perfect. And when he doesn't grade it, I feel better because I can ask more questions than if it would be a grade, and I just feel more comfortable.
When he doesn't grade it, I kind of lose some of the stress that I have on the assignments that he is grading. And like, he doesn't say that he's not grading it, he just won't grade it. Because he wants us to still put that same effort into it and still work on it and try to like get better off of it.
When you have finished, you may go and put your boards up.
As emphasis is placed on deeply understanding and implementing the concept of powerful math practices, ask yourself the question: to what extent is formative assessment data used to adapt teaching and learning in your classroom, your school, and your district?